Hello everyone, welcome back to our 30 days revision series for UPSC CSE Prelims 2026. Today is day number 5 and we will continue our practice with CSET previous year questions along with the key concepts behind them. Now coming to today's topic, we will be solving question from permutation combination, a very important and often tricky area in CSET. Let's begin our today's practice. Now question number 1. In an examination, the maximum marks for each of the 4 papers P, Q, R and S are 100. Marks scored by students are integers. A student can score 99% in n different ways. So what is the value of n? So in this question, this is a very important line where you can understand a student can score 99% in n different ways. So this is a question related to permutation and combination, and we can solve this question with the help of one important identity, that is number of solution. So let's start. Now total marks are 400 and students can achieve 99%. So 1% equal to 4 and 99% we can find 400 minus 4 equal to 396. So 396 is total marks student get in all 4 subjects, but we have to find out in how many ways he can get 396. So here's one very important property on concepts. There's a number of solutions. So we can solve with help of this 4. This is a lost number. And we know that the total number of solution, the properties here, x1, x2, x3, x4 equal to r. So number of solution is n plus r minus 1. This is a formula. Please remember, this is very important and can solve many questions related to permutation combination, as well as also in geometry it is very helpful. So x1, x2, x3, x4, we have total 4 variables. Similar way, in this question we have total 4 variables. Suppose y1, y2, y3 and y4. These are lost numbers. Suppose total student get 100 marks in ideal condition, but as per the question student didn't get 100 marks. So suppose student get 100 minus p marks. So this is a lost number. 100 minus p, suppose it will become 2, 1, any number. So this is a variable. So y1, y2, y3, y4, total we have 4 variable, and result we have 4 because this is a lost number. This is total lost because 1% is equal to 4. Now we'll put in this equation 4 plus what is r is also 4 minus 1 c, and here r is 4. So we'll get 7 c4, and you can solve factorial 7 divided by factorial 7 minus 4 multiply by 4. So with solution you will get 35 as an answer. So there are total 35 ways students can get 396 marks. Now question number 2, and please read carefully. One non-zero digit, one vowel and one consonant from the English alphabet are to be used in forming passwords, such that each password has to start with vowel and end with consonant. So how many such passwords can be generated? So what is the condition? Condition is that each password has to start with vowel. So initially start with vowel and end with consonant. Now we can change in midway. So now let's start solving this question. So first we write the concept behind the problem. So as per the instruction given by question, one vowel, one consonant, and one non-zero digit. Now we will arrange this. So first one vowel, second digit must be non-zero, 1 to 9, and third consonant. So as we know that total vowels 5, A, E, I, O and U. Consonants total 21. 26 minus 5, 21. And we have digits 1 to 9. Means total we have 9 choice. Now as per the instruction by the question, initially we have to put vowels. So what will be the total? First vowel in 5 ways. Now second digit 1 to 9, 9 choices we have. And third consonant in 21 ways. So after multiplication we get 945 and this is our final answer. Why we multiplied? Because all are independent. This is a property. If all are independent, we can multiply to get answer. Now we'll see some more cases. Some twist may be asked in examination. In previous question, vowel and consonant are fixed. Position are fixed. Only variation in digit, which is also like a fix because we can't change here or there. But in this question, I just change to make some twist. Suppose two positions can be in any order and password must start with a vowel. First one is fixed but two is position, second and third can be vary. So we can write first vowel 5 multiply by 9 into 21 and again multiply by 2. Why? Because swapping is possible. 9 can come to 21 and 21 can go to position at 9. So we will get answer 1890. Another case, one vowel, one consonant and one non-digit are used to form password. All arrangements are allowed. Now no limitations. So in this case V, D, C means vowels, digit and consonants can arrange anywhere. Positions can be changed. So there is a factorial 3 for position and remaining are same like a previous question. So we'll multiply by factorial 3 and we will get answer 5670. One more case. Now one more twist. Similarly, our main question, password must start with vowel, end with consonant, but here's the catch. In middle there is no fixed digit. There's no confirmation. So end with repetitions is allowed. So here maybe vowels, consonant and digit. So it can be 5, 21 and 9. So there is a 35 way. So now total 5 into 35 into 21. So you will get 3675. So we saw some possible cases. Now next question. Now question number 3. There are 5 persons P, Q, R, S and T. each one of whom has to be assigned one task. So total we have 5 person and 5 tasks, each person assigned different task. So neither P nor Q can be assigned task 1 and task 2 must be assigned to either R or S. In how many ways can the assignment be done? Now we'll start our solution. Now as per the question, we have 5 persons and 5 tasks. Suppose there are no restriction, so it will become factorial 5 or 120 ways. But there are some restriction. Restriction number 1, task T2 completed by either R or S. So now we'll make one case here. Case number 1, task T2 completed by R. So who will remain? P, Q, S, T. 4 person remaining. And second restriction, P and Q cannot do T1 task, task number 1. So who will do task number 1? Either S or 2, S or T. So there is total 2 ways to do that. So now remaining 3 person and 3 tasks in case number 1, because T2 done by R as per our case number 1, T1 done by S or T. So now 3 person and 3 tasks remaining. So it will become factorial 3 and we can write 6. So total for task T2 or case 1, 6 into 2, it will become 12. Now we will see case number 2 where task T2 completed by S. Now who will remaining? P, R, S, T. So this is similar like a first case. So we'll get 6 into 2 and get 12. So total 12 plus 12, 24 will be our answer. You can practice some more questions and there are some standard formulas with cases like hand check type of question where you can apply n minus 1 by 2 directly in this type of question where no conditions given. Circular arrangement factorial n minus 1, linear arrangement factorial n, selection, permutation, repetitions and identical objects. So there are some cases you can practice this type of question also. Now question number 4, there are 9 cups placed on a table arranged in equal number of rows and columns, out of which 6 cups contain coffee and 3 cups contain tea. In how many ways can they be arranged so that each row contains at least 1 cup of coffee? First of all, we will understand the arrangements. 9 cups arranged in equal rows and columns. There are 3 cross 3 grid. And we have total cups 6 coffee and 3 cup of tea. Now total ways, suppose there are not any restriction. So total ways total we have 9 cups. So there are 84 ways. We can solve it like factorial 9 divided by factorial 3 into 9 minus 3, 6. So we'll get 84 as our total ways without any restriction. But in according to question, there is one coffee, at least one coffee cup in each row. So in this case, we have to think like a reverse order. Suppose there's an invalid cases. What is invalid case here? All are T comes. And there are total 3 ways to arrange. So 84 minus invalid cases at T1. And this is our answer. So that's it for today. For any queries, you can connect with me on LinkedIn or send an email at info@macroedtech.com. Thanks for watching. The next session will be on Monday, April 27.